In this lesson, we are going to be multiplying and dividing with monomials. But first, we're going to review what our lesson was yesterday. Yesterday, we were writing the prime factors for numbers. So remember, we were looking at the prime numbers 2, 3, 5, 7, 11, 13, 17, and it keeps going. That's probably enough for us. We're always going to start and see if it's divisible by the smallest prime number. So if it's even, start with 2. 100 divided by 2 is 50. 50 is even, divisible by 2, 25. 25 is not even, it's not divisible by 2. We go to 3, not divisible by 3, so we go to 5. It is divisible by 5, and 25 divided by 5 is 5. Here are our prime factors. So when we write it in exponential form, that would be 2 squared times 5 squared. And our next one, 150. It's even, so we divide by 2, which is 75. 75 is not even, so we go to the next prime number, which is 3. It is divisible by 3. 3/4 is 75 cents, so 75 divided by 3 is 25. 25 is not even, so we go to 3. It's not divisible by 3, so we go to 5. It is divisible by 5, and that is 5. So the prime factors are 2 times 3 times 5 squared. We factored monomials yesterday, so here we start with the monomial of, or the coefficient of 54. It's even, so we divide by 2. When we divide by 2, that would be 27. 27 is not even, so we see if it's divisible by 3. It is, which is 9. 9 is not even, so we try by 3. It is. So we have 2 times 3 times 3 times 3, so we write it with exponents. It would be 2 times 3 cubed, but since we're factoring, we're going to write it out separately. 2 times 3 times 3 times 3 times a times a times a. Remember, when it's negative, we have to start with a -1. Then we take the coefficient of 33. It's not even, so we cannot divide by 2. We go to the next prime number of 3. It is divisible by 3, which is 11, and 11 is prime. So here's our prime factors. So we write it out. We have to start with the -1 times 3 times 11. We had t squared, so that is t times t. We are going to practice evaluating. If we plug in some numbers, up here it says that x is equal to 2 and z is equal to -3. When we plug in those numbers, especially when it's negative, we need to put it in parentheses because it changes the way we evaluate it. So in place of x, we put 2 multiplied times -3 cubed. When following our order of operations or our PEMDAS, we have to do exponents first. So we're doing -3 cubed, which is -3 times -3. I'll do it with parentheses, times -3. That would give us 2 times a -27. So that would be -54. Okay, in our next example, where we're practicing solving or evaluating, we have y times the difference of y minus 1 squared. So when we plug in the numbers, we're going to plug in 4 for y. So that would be 5 times the difference of 4 minus 1 squared. According to PEMDAS, we have to do our parentheses first. 4 minus 1 is 3. Next, we have to do our exponents. So we have 3 squared, and 5 times 9 is 45. We're going to look at multiplying with monomials. Now, as you're taking your notes, there are some mental steps that you're going to be doing on your assignment. But instead of writing down just the answer, that won't help you with your notes. You need to write down the steps that you're doing mentally, so when you look back at it, it will actually help you. So when you have 4 cubed times 4 to the 5th power, what you really have, and here's what you need to write on your notes, 4 cubed means 4 times 4 times 4. 4 to the 5th power is 4 times 4 times 4 times 4 times 4. This is just what you know. So it helps to show you what you know on your notes. Now if you look here, what do I really have? Well, I have 4 multiplied times itself 8 times. So that would be 4 to the 8th power. Now, you could evaluate 4 to the 8th power. You could type into your calculator 4 raised to the 8th power, and you're going to get 65,536. Now look up here to see what we did. Actually, see this 8 right here, the exponent of 8? We had a 3 and we had a 5. But what did we do with those exponents to get an 8? We actually added them together. So when we're multiplying with monomials, what you're really doing, as long as the base is the same. So in this first example, the base is the number in front of the exponent. The base is 4. Since the base is the same, we know that we have 4 3 times and then 4 5 times, and all together that's 8. You just had to add the exponents together. So in this next example, we have a base of 6. We have the same base. You do not see an exponent on the first 6, so it's understood an invisible 1. So you have 6 one time. Then you multiply that times the factor of 6 4 more times. So how many times are you multiplying 6 times itself? Well, this means the same thing as 6. That's the 6 to the first power. 6 times 6 times 6 times 6 is 6 to the fourth power. So that would be 6 to the fifth power. Or if you typed into the calculator, 6 raised to the fifth power, that would be 7,776. So there's a rule that we follow. What rule do you see for multiplying with exponents? If the base is the same, the exponents are actually added. And you can see why that is true up here, because we had 3 4s right here, we had 5 4s right here, we add them together, and that was 8 altogether. Here we had 1, and we had 4 more, so altogether we had the base of 6 5 times. So the rule for multiplying with exponents is, as long as the base is the same, you add the exponents. So let's look at this. 5 squared times 5 cubed. You have 5 times itself 2 times, and then you have 5 times itself 3 times. So if we add those together, we would have 5 to the fifth power. On your notes, I want you to go ahead and show what this means. It means you have 5 multiplied times itself 2 times, 5 multiplied times itself 3 times. So that's 2 plus 3. So our new exponent is 5. And if you were to evaluate that with your calculator, you would type in 5 raised to the fifth power, and you would get 3,125. In the next example, we have 12 to the third power, or 12 cubed, times 12, which is the same thing as 12 to the first power. So on your notes, you have 12 3 times, multiply times 12 one more time, and 3 plus 1 is 4, so what we really have is 12 raised to the fourth power, which is 20,736. So remember the rule with multiplying with monomials. If the base is the same, you just add the exponents. So what do you think this would be? B squared times B squared. B to the fourth power. Now let's look at this one. We're getting a little bit more difficult. Now we have 2x cubed times 8x to the fourth power. We're going to use the commutative property. We're going to look to see what we can group together to multiply. I can multiply a 2 times 8, so I'm going to group them together. And I have the same base. I have x cubed times x to the fourth power. Since it's the same base, I can multiply them together. Well, we know that 2 times 8 is 16. And here we have the same base with 2 different exponents, 3 times 4, or 3 and 4. So remember, when you have exponents, you're actually going to add them, and that would be the base of x being multiplied times itself 7 times. So it would just be 16x to the 7th power. Here we have negative n as the base. You multiply itself times 3 times, and then you multiply it times itself 2 more times, and if you add 3 plus 2, you get negative n to the 5th power. Remember, for note purposes, please write this step down because it shows you what this actually means. If all you do is write an answer down, you may look back at it and not know what to do. So again, we're going to use the commutative property. So we can group together 5 times negative 3. And 5 times negative 3 is negative 15. Then we have x squared not x, it's a squared and a to the fourth power. That means we have a multiplied times itself 2 times, and then we have a multiplied times itself 4 times. So altogether, that's a being multiplied times itself 6 times. We add the exponents. Negative 15, a to the 6th power. Okay, now let's look at dividing with monomials. What happens when we're dividing with a base with exponents? Okay, again, for no purposes, please write down the following steps. 8 to the 5th power divided by 8 to the 3rd power means this. It means you're multiplying 8 times itself 5 times on top, and you're dividing that by 8 multiplied times itself 3 times. So here is 8 to the 5th power divided by 8 to the 3rd power. Now when you're doing this, if we just look at it this, 8 divided by 8 is 1, so that cancels each other out. 8 divided by 8 is 1, and another 8 divided by 8 is 1. So those, as long as you have something in the numerator and something in the denominator that's the same, they cancel. We call it canceling each other out, because when you divide, it becomes a 1, and 1 times any number is the other number. Now what's left over? We have 2 8s on the top, and what is 8 times 8? Well, it is 16, so it's 8 squared, or 16. Now, look what we did. See this? We had a 5 and we had a 3. Can you see what we did with the exponents to do this? We didn't divide them. We actually subtracted them. So when dividing with monomials, we're actually going to subtract. It shows it. Okay, and the next one, we have 3 to the 4th power divided by 3 to the 1st power. So that means 3 times 3 times 3 times 3 on the top, divided by 3 on the bottom. So one of the 3's on top cancels out one of the 3's on the bottom, or the only 3 on the bottom, and what's left? On top you have 3 multiplied times itself 3 times, which is 3 cubed, or 27. Notice again we subtracted the exponents. We had 3 to the 4th power minus 3 to the 1st power. So 4 minus 1 is 3. So what is the rule for dividing with exponents? You subtract the exponents. So in review, when multiplying, we actually added the exponents. When dividing with monomials, we actually subtract the exponents. And if you write these examples on your notes, you will see why that is true. So here we have x to the 7th power divided by x to the 3rd power. So we have 7 x's on the top, 3 x's on the bottom. So 3 of these get canceled out, and what is left? We have 4 x's on the top, so all we had to do was subtract x. All we had to do was go 7 minus 3, which was x to the 4th power. In another example, we have the base of negative 4. We have negative 4 4 times on the top. We have negative 4 twice on the bottom. 2 of them get canceled out. What is left? Negative 4 twice. So all we did is we did the base of negative 4, and we subtracted the exponents and got negative 4 to the 2nd power. When evaluated is 16. Okay, so in review, when adding with exponents, when multiplying with exponents, you're going to add them. When dividing, you're going to subtract. Good luck.